Welcome to another video tutorial. In this video, we will be building an IoT solar-based feulless generator. The generator will be recharged by a 20 watts panel on the backup battery. It will power the alternator that will generate DC power. The project can be monitored and controlled remotely from anywhere around the globe using Blink IoT Dashboard. You can equally switch on or switch off the generator from the dashboard remotely too if you want. Without further ado, let us get into how the project was made. First we begin with the mechanical assembling part. This is made up of the various sets as shown in the diagram here. To understand what each part does, see the blog post in the description link below. The mechanical system is made up of the disk, the DC motor, the DC generator also known as the dynamo, the 12 volts battery, the 90-degree angle poles, the framework used to hold the design together. We added an override switch to manually turn the system off in case of emergency. We use the solar panel to charge the battery, the charge controller to control the charging rate and two bulbs to show our generated output. As preamble to see if we can generate DC power, we fired up the system and we could see that the light bulb glows once the system starts spinning the disk. The voltage generated though can be above 12 volts DC because the faster the dynamo spins, the more voltage it generates. Now, let us design the remote controlling part of the project. This will be the core electronic programming parts. The circuit diagram shown here is further explained in the blog link down in the description. It tells you everything you need to know and the various parts and modules needed for this project to work. Please endeavor to visit the blog post to ensure you grasp fully the design tutorial steps. Assembling the components directly, we used a hot glue to hold the component like the LCD module. This would help us by displaying the voltage level generated by the DC generator, the state of the bulbs etc. We cut an opening where it will be easier to program the Node MCU board, then we glued the soldered board to the base of the casing, ensuring it stays firm. The circuitry has already been soldered and the Node MCU microcontroller connected onto the printed board. We connected 3 single-channel relays, however, it is recommended to use a 4-channel relay module. A voltage sensor used to read the voltage output from the DC generator is connected also to the Node MCU. Once the major connections were made, we used cable ties to finish up the cleanup, neatly arranging the wires in the box casing. The next step is to connect the output bulbs, hence we start with mounting the lamp holders for these. Next, is the mounting and connecting of the charge controller. This would help us control the rate of charging of the backup battery. After this, we mounted the 20-watt solar panel frame and placed the solar panel on top of it. The whole setup would look like this at the end of the coupling. A full, well-presented and portable IoT solar-based Feulless generator design. Let us know in the comments section if you like this design. Next, let us create the Blink IoT Dashboard to monitor and control the project design. If you don't know how to set up your Blink dashboard, go to the blog post or leave us a comment below. The Blink IoT Dashboard would look like this when it has been set up successfully. You have 3 button switch widgets to control the state of the generator and the state of the light bulbs, and a voltage display widget to display the voltage level generated by the dynamo. To set up the Blink dashboard on the mobile phone, it is pretty simple. Just download the app from your favorite app store, open the app, connect your device. Programming the project design, go to the blog post in the description to download a free copy of the sketch. Project design. We can test the project remotely from anywhere in the world, or we can also test it on site. First, we test the project design remotely. The LCD display, however, isn't showing the accurate voltage measuring. This can be corrected in the source code. Now, testing the project on site, we can see how we control it using the mobile Blink dashboard. We can see the voltage generated under the effects of each widget control.
Okay, sir. Alright, sir. Go. Oh. Alright.